Booth this morning. Yes.
I have a quick question about the homework.
Uh-huh.
Will you please explain what actually reshape does or
Reshape.
Yeah.
So, in general, when we have an array that has more than one dimension, then in order to read the data correctly, I need to know precisely what is that I have stored. Right? And I can change that back and forth. So basically when I have rows here, right? And the way Python chooses to store the data is to go row by row and do all of the elements in sequence. So in memory, I don't have a block, two-dimensional block in my memory in the computer. Okay? I have a continuous memory that is essentially one dimension, the way a computer thinks about it. So I need to figure out how to store the data and also present it to the user. But user has a mind on its own. So user sometimes needs it in certain shape and sometimes in a different shape. So sometimes you want a matrix to be 4 by 4, and sometimes you just want 16 numbers in one row, because you might be doing linear algebra with it, right? So you might want to go from one shape to another, from a 4 by 4 matrix that has 16 numbers to a 16 by 1, right? And actually, we're going to do reshape as we read the data, so possibly it's going to make a little sense, because when you read the data in, you're just kind of often going to read in a continuous stream of numbers, and you need to kind of reshape that into something that you need. And that's where you need the reshape. Does that answer your question? So again, like in order for you to manipulate the data or to possibly do some linear algebra operation with it, you need it in certain shape, in certain order. Computer might have it in a different order for whatever reason. Whoever wrote the data wrote it in certain order because that order made sense for them, or was easier for some reason. Maybe it was the tool that was recording the data, and therefore data came in certain sequence. But you need to do something else with it, right? So you have something else in mind, and that's why reshaping kind of needs to be there as a tool. It's really just a tool. So often, for majority of this, and that actually continues really well in what I want to talk about today, you have to know what's written in the file and how is it written and how do you want to read it. If you don't know what's written in a piece of memory, you won't be necessarily able to do much with it. Now, we are used to certain files that immediately just open on our computers. For instance, images are one of those. Images are now everywhere. Okay? And your phone knows precisely what to do with them. It can manipulate them. It can add those funny little characters on top of your photographs and whatnot. Okay? But that means that phone knows precisely what it's actually trying to look at. Okay? If that app on your, is it Snapchat or whatever it is, that app can place little horns or hearts or whatever it is around your head, that means that the app knows where the head is in that data. Okay? So app knows precisely how to read that. If somebody took an image of themselves, app knows, there will be a face, and I can go and look for that face, and once I look for that face, I can do stuff to it. Okay? So there's a lot to be said about knowing what the data is. Now, as petroleum engineers, you will not work with Snapchat type of data. Okay? You will not necessarily work with photographs that have people's faces in them. You will work with data that has permeability information, porosity information, you name it. And that data has a completely different format in the way it's stored in the file. So you will have to kind of just work with numbers and what those numbers are and create information and make decisions based on that information. Okay? So there's a lot to be said of like knowing what it is that you're trying to read. Okay? Now, in the files, there's some sort of common files that everybody uses, like photographs, then it's easy. Then all of our systems already know what they're doing, right? going to work with specialty files. And those specialty files are likely to have very large data sets within that have 5,000, 10,000 contiguous numbers that mean something only to you, okay? Because you're a reservoir engineer, production engineer, biologist, analyzer, petrophysicist, you name it, okay? So in that sense, you kind of have to be in tune with what the data is. And we're going to do a very simple exercise in that, but I want you to have in mind that you might store something on your computer, but you kind of have to know what the format of what you're storing is and how to get it in. And we're going to do a very rudimentary exercise in that, to the point that you're going to be like, really, Dr. Blanish? You kind of know these things? But just to get you the feeling of it. So let's get started. Or let's rather continue. Where I'm going to open back up the file we started. I called that file 2.6 Spring 2019. I'm calling these are input-output exercises. So question is, how do I communicate that data back and forth between me and computer and any kind of user on the computer? So very simple exercise that started last time is this input command that will just give user a prompt. This is a string, remember? String is just a text or something that computer recognizes as text. Otherwise, they're actually numbers underneath, and there's a code that translates those text to numbers and back and forth. But we recognize it as writing, right? So this is specifically human, the text. Okay. And we're using the English language, but there could be also different languages here behind, and the codes that kind of translate those languages would work differently for different languages. So in any event, name says, hey, what is your name? So what is your name is just what is going to be printed to me at the screen so that I know what to do. Okay? So you design what to do. So I say, hey, I'm Masha. And then there's an appearance of intelligence here when you actually let the computer say, oh, great, nice to meet you, Masha. Right? But really what I took this answer from the user and I printed two pieces of information. One is this line here, and the second one is name. So you can use this print command. So far, we used print command just to print whatever numbers I had or whatever other variables. You can print any variable. And here what I'm telling you is that you actually can compose stuff with it. So here I took just another string, and I printed that string, comma, this string. I can actually do whatever. I could have printed, how old are you? 41, print age. So let's just walk through this once again. So then I can also input my age. The thing with that is if I printed, yes, age will be 41. But computer really understands it as text, not as numbers. And if we want to work with this as a number, do addition, multiplication, division, whatever it is that numbers normally do, then I have to convert it. So this is precisely the point I made earlier. It might have an appearance that the computer knows what's underneath, 41, but it's actually taking it as text. He thinks maybe I'm named 41. It doesn't know really whether what are those? It's just taking 41 as text. And if I want to work with it as a number, I have to convert it, okay? So if I really type this age, it's going to be a string, but if I convert it into integer, okay, then it works with it as a number, okay? Otherwise, if I attempt to do this age plus 2, print age plus 2. It might not actually, I have to re-execute this. So I'm going to just execute all of the, great, nice to meet you, Masha. How old are you? And actually, I'm going to execute this with a space. Stop. So sometimes, right now, this star means that it's executing. That probably because I was trying to execute it and then I retyped something in that same cell and that got it confused. You can stop execution. Did you see the detail? Let's try. Now it's gonna be, yes?
So say that you have a float 4.5 and you want to convert it to an integer.
Then you're gonna, then it's gonna chop it off.
It chops it off
So
and
yes,
you
so
would-
let's give that a shot. So let's say that I'm asking and say, I am actually 41 and a half. I'm not precisely 41. Right? My birthday is in August. So I'm on my way to 42. Okay? So if I say 41 and a half, it's going to take that. If I print it, it's 41 and a half. If I check the type, it's string. Now if I try to do integer of it, it doesn't like it. Now normally if I was converting, let's see the difference. If I was trying to do float, it'd be fine because float makes sense. This is a floating point number. If I want to convert this floating point number, if I was just converting 41 and a half into integer, I can do print integer of 41 and a half. I believe it would recover. But this one, at some point, it's just not smart enough to do all of those conversions. So you kind of have to do them step by step. And that you have test. My guess is 2 years from now, it's going to do this conversion just fine. The one that I tried initially. 41.5 into. Because things get better and better. There's a little bit of programming behind that takes the text, tries to recognize all of the numbers inside, and then converts it to an integer just by piling up digits together. And right now, that conversion that is happening is confused with the dot. So if you have any special characters, it's not going to work well. But if it's relatively simple, it will. Again, there's a piece of programming behind that is trying to recognize. Okay? If you are doing search these days, and you go to your favorite search engine, you start typing something in, it's trying to give you suggestions, right? That's not mind reading. It just knows and collects the data of what everybody cumulatively is searching for. And it's trying to search. It could also try to go to the dictionary and just try to continue the word. Okay? So it basically searches through its databases sometimes, or database of the information that it has already, and tries to. So there's a piece of programming that is helping it out and helping you out. Okay? So that's how these systems appear to be smart. So there's basically some programming behind it. And again, my guess is that right now it knows, so if I tell it convert to float, it's actually going to search for that dot that is supposed to create a floating point number. Okay? But if I don't do that, then it doesn't know to search for it and gets confused if I want to get an integer out of it. So again, the problem is that this doesn't work. If I type in 41.5 dot character will confuse conversion to the integer, because it doesn't know to search for the dot. So things sometimes just might work if somebody has thought of programming it, okay? And my guess is, again, that 2 years from now, this will work, because things continue to improve. And somebody will like, hey, why don't we add this, and if there is a dot in there, figure out that it's a float, do a float first, and then convert to integer, right? Because it obviously knows how to convert to a float. Any questions, or what this information just kind of went about? Yes? No? Did it sink in somewhere? All right. So again, we need to know what it is that we're reading for. So let's now actually move on and try to actually write this data back into some sort of a file. So let's say that for some reason I want to record this sentence. Okay? So first thing first, we're going to learn how to write a simple text file, the one that you would email. Okay? It's not necessarily engineering data, but it's some sort of information. So first, so this is, let's try to write information into a simple text file. Okay. So file is an object, it's a specific object that has to have an address. Think about it like a little house. Okay? That house has to have a street and a number, an address. How do I get to the house? Then I have to be able to open the door, get into the house, and if I'm looking for people in the house, I need to go and scan the rooms and find the people. And once I'm done with whoever I found, I get out of the house and close the door. If I leave the door open, things in the house might disappear. Okay? Same thing with files. I'm going to be able to find a file. Okay? If I'm creating a new one, it's like building a house. I got to do the site, figure out the plumbing, get things to the house, right? I just went through construction, so trust me, it's not so easy as opening a file. I wish it was. So basically, you actually have to allocate some space for it, okay? And get somehow it wired so it can be found later. Okay? So first thing is getting an address and then some amount of space. What do you do when you don't know how big is the house going to be? Well, you give it a standard plot size, 0.1 acres, thank you for asking. Okay? So standard plot size is typically around 0.1 acres, so that's something that you allocate when you don't know. So there are certain default values for the size of the file that you find. And then that file is ready to accept some information. Okay, to start building on it. You go and put some data in it, and after that you want to close it so that you don't lose that information. Okay? Now you can also think about these little, like when you're opening the file for reading, think about like sending a little librarian to a place you're going to start putting books. And then closing the file is moving that librarian back, okay? Closing that shelf so that you don't lose any information from it, and making the librarian available to another person. Okay? So there's certain management in your computer that has to work. So that's why we have to open and close the file. So let's open the file first, and we will let it know a specific task we want to do, and that is writing. So I'm going to say my file is going to be the name of my file object. And open is the command. I'm going to give it a name. That's the name I give it. Computer gives it another name that associates with this. And I'm just going to say simple text file. And this is again for me. I'm going to call it txt just to know that it's a text file. So that's a standard ending for text file. I was mentioning images earlier, JPEG for instance. That's a standard ending. There's a format behind it. So the file that is JPG or JPEG has to be written in a specific format that is associated with it so that the program can go in and read the sequence information in a specified way, can open an image after that. Okay, and oops, didn't mean to do that. And I'm gonna say, hey, open it for writing. I can open file for writing, which is W, for reading, which is R, for appending, meaning adding the information at the end of the file, which is A. Okay. So if I execute this, nothing really happens because it opened the file, but there's nothing to give back to me. I'm actually going to continue writing in the same cell. And then file is an object, meaning that there's not just like opening it that comes along with it, but there are certain commands or built-in functions that come with it that I can use, and one of them is writing. So I can simply say my file write. This means that this writing command is associated with the object called my file. And now I just put the text in there. I'm going to say my name is. And I can just continue. So this write command works very similar to that print command, right? I can just tag things along. I'm going to put the full stop afterwards. And one thing that I want to add, and again, I can actually do multiple write commands. I can do everything in one. I can actually do it in multiples. It's up to you. I'm just going to exemplify it here. I'm going to also tell it, go to the next line. Now, next line in itself, it's easy to just press enter on your computer or return, and it's going to go to the next line. How do I write that to a file? Because here, if I press enter, it's going to execute this command, right? How do I write it to a file? So I have a special character that means precisely that. Okay, so we have to resort to a special symbol to let it know, hey, go to the next line in your file. This is the symbol. And I'm gonna continue my story. I am. And I'm now gonna play, so I can do away with commas. I can also do things with pluses, if you remember. So I'm just gonna do, for fun, whoops. And I hope you tailored this to your name and your age. That was the point. So this is just to show you variability. So again, I can write any number of write commands as I'd like. I could have done this next line in my previous line. It doesn't matter. It's really for me to break it down, so it's easier for me to read what it is that I'm writing. And I can either kind of put information together with commas or with these pluses. And write, in that sense, works like print command. It's just going to print into a file. So it's as if I had a print command that is associated with this file, so all of the information goes to the file instead of to the screen. Okay. So that's another thing with any writing and printing and whatever. Computer has to know where should information go to. So depending on where it goes to, screen, file, some other third place, it could go to your phone. Okay? In which case you would have to open some sort of a secure Bluetooth connection between your computer and your phone, and then let it know to send that information to your phone. That's possibly what you're doing if you're sometimes watching Netflix and projecting it on your TV, right? There's a Chromecast or whatever it is, or different ways to do that. That's precisely what it's doing. It's saying, hey, instead of displaying that on this screen, just open some information channel and send it to a different screen. Or both. Though that never really works for me at home properly. If it's on both, it has issues. Okay. A little too intense. Memory-wise too intense. And then once I'm done, I'm just going to say my file, close. Close the door. If you leave the door open, you might lose that TV or computer or both. And now I have some issues. Oh, it doesn't like my comma, it just wants pluses, is that it? Let's try with plus. Seems that I might need to do just pluses with the right command. Yep. just pluses with write command. So, it seemed that it opened the file. Hopefully it has written something into the file, and then it closed the file. How do I know? Huh? Good question. So where should it be? I gave it a name. If I don't tell it anything else, it's going to be in the same folder location where this file is, Lecture2.6. So where's that on your computer? For me, I'm right here. This is where my lecture is. This is where I opened it from. So I need to possibly refresh this. And if I refresh it, simple text file, a minute ago. Okay? So if you don't tell it anything else, it's going to be in the same folder. You can also navigate to it. This browser is reading the folder contents from your folder where somewhere. You can also navigate to it from your computer. And it's a text file. Browsers know how to display simple text file. So I can actually kind of open it and read it immediately. Okay. And this is what I wrote into the file. So if I skip, now try playing with this. Where's my... no, that's not it. Ah, this is it. Try playing this, and let's turn this off. So I'm going to comment next line. Okay. And let's redo it. And then let's refresh this. Or maybe it doesn't like refreshing. I'm gonna back to this and reopen it. What's the difference? So it didn't go to next slide. So it did precisely what I told it to do. Or I didn't tell it. Another thing is that I lost my first file. Okay? So when I open for writing, it opens a new file for writing. If I had a page of text here, I would have lost it. It didn't ask me, hey, do you want to overwrite this file? It just did it. That's the type of behavior that you learn only by trying it out. Okay? Some other smarter programming environment would have possibly asked you, hey, by the way, there's already a file under this name of the system. Are you sure you want to proceed? Okay? Here, it didn't, because we are programming it, so it didn't do it. Right? So be careful. Okay. So now we wrote the information in the file. We're going to learn how to write the little smarter files with better data that are just numerical data a little later. Let's now actually read the file. So I have posted file for you, temperature.txt, also text file. Please download it from Canvas and put it in the same folder. So when you download, it's probably by default going to go to your downloads, wherever that directory is. So download it to your downloads and then move it to the folder you're in right now. This is how this file looks like. And our next task is to read this data. It's actually temperature data. So being a temperature data, I'd like to do something with it. I'd like to get hold of those numbers. They're numbers. They're clear numbers. Temperature means something to engineers. Right now, it's written in your files as text. You can email it as a text. You can put it in a letter. But if you want to plot it, you need those numbers. And not just to read them, you don't want to retype them, you just want to grab that information and plot it. So, not only that, I have a mix of text. First line is text, and the rest are numbers. I can't plot text. I need to read it as text and then get rid of it. It's meaningful because it tells me that the first column is month, second column is high temperature, and somebody has to tell me that this is temperature really. I'm telling you, it's the name of the file, right? This is low temperature, this is the average temperature. Is it in Celsius or Fahrenheit? Celsius. Where on earth do we have 80 Celsius degrees? This is engineering knowledge that needs to be, right? This is just data. The rest is you. You need to know what this says. And use your judgment if there's no information presented. This information on top, it doesn't say this is temperature in Fahrenheit degrees, right? The file name says temperature. The rest is sometimes left to you. Okay? So use your engineering judgment. Is this in Austin?
No.
Month of August, high temperature of 80 would be nice. It's probably low temperature of 80 overnight. If it's kind enough to cool below 85 degrees, right?
How much is that in Celsius?
Celsius, 80 degrees, 80 Fahrenheit. In Celsius is not even 30. Okay, it's like 28-ish. 85 is about 30 Celsius degrees. Okay? And here it's about 40, decidedly 40 to 42 Celsius degrees in August, okay? So this is not in Austin, it's probably somewhere north. If it's high of 80, I'd say, I'd judge that's Wisconsin or something like that. Low, no,
It's like California.
Wisconsin is colder than 33 degrees Fahrenheit right now.
It's like California.
California, yeah, that sounds about right. All right, so this is temperature. So again, this is the information. We want to get those numbers. Let's give it a shot. Let me navigate to. So now I want to open file for reading, okay? So I'm gonna now say my file, and I'm using the same my file designator, which is now going to get overwritten. And I'm gonna say, hey, open temperature. And this file better be now in your directory where you're at, or otherwise you'd have trouble finding it. But now open it for reading, not for writing anymore. If you want to open it for writing, you will successfully erase it. So nothing happens, so that means nothing happens is good in this case because it found the file. If you have an error here, that means that your file is not in the same folder as this notebook. Okay, so I have a combination of text and data, and I will have to read accordingly. Or I can read everything as text and then be busy converting my text to numbers. And given that in each line I have 4 numbers, that could be a little bit troublesome. Okay? So we're going to actually use 2 tools. First one is just to read the text, and it's literally called read line. So I'm going to, first line is my file read line. So read line is a command that comes in together with every file. It's just going to read a text line, first line from the file, up until that special character for going to the next line. And that special character is often not visible to us when we are reading the file, but it's there if you see that the data is connecting in the next line. So here, there's a special character here that it's not letting me know it's there, but it's there because the data continues in the next line. Okay? So that's how it knows there's a line. There's a hidden character. So not all of them are shown. Cool. So let's actually print that first line. To see that I got what I... Okay, yeah, that was in the first line. I could now continue. So this little reading tool. It goes through the first line, grabs all of the information, and then it's sitting there, okay? And now it's ready to read the rest. So it's like a little pointer that moves, okay? Now this rest, all of the rest are numbers. So I'm gonna switch my reading tools to something that is smart about numbers being there and reads them into a NumPy array that I can work with. Otherwise, I would have to read it as text and then convert it. I don't want to go there. I mean, I could do that, but that's for hardcore computer scientists, okay? So we're just going to say, hey, we have a smart tool that is going to read this into a NumPy array. Let's switch to that tool. So now, switch to reading numbers with a smart NumPy tool. Now, note that I still have to know that. I'm looking at the file. I need to know that I need to switch. So I have to look at the file and decide. Otherwise, I'm guessing. And this, I'm going to call the rest data. This tool is called np from file. And it's quite a general tool. So I'm first going to tell it which object to read from. That object is this file that I opened. So I have to have a file that is already opened for that. My file. I have to tell it what the data type is. Remember that exercise at the beginning of the file of 41 versus 41.5? Okay. And recognize it. I actually have to tell it. So I'm going to say data type is, type. I don't know how to type. That's a geeky joke, sorry. So that type is float. And float turns green, meaning that it recognizes it as something that it knows. And then I'm going to tell it also count. How many numbers do I have?
36.
12
48.
times 4 is 48. So I'm going to literally put that. I can put 12 times 4 just to remind myself, hey. Or I can put 48. Either way it works. And then separation between those numbers, because it has to figure out where the number starts, where does it end, is space. It could be comma, it could be space, it could be tab, which is multiple spaces, and so forth. Again, there's a little bit of formatting in this file, and I kind of have to tell it. It's not smart enough to recognize everything. Great. And then after you're done with reading, close the file. And I want to figure out, hey, did it actually read the data correctly? Print this data. So I have to give it a bit of information, but if I do it successfully, I'm just going to get this data array as numbers. And I'm going to also say print just to show you type of data. Woo. Invalid syntax. That little detail. So now it's going to, I cannot print it in the same cell because I closed the file. I'm going to go to the next cell. Okay. I have to start all over again. What am I missing?
Because mine gave me an error from NumPy.
I opened this file new this morning, and we didn't have NumPy in it. Okay. So now this was done correctly without complaints. Now let's print the data again. So the type is indeed NumPy array. So it's treating this data as numbers. And here's the data. What is the shape of the data? This goes back to the very first question we dealt with today. All 48 numbers in one. And what does it appear that it did? 1, 45, 33, 39. 1, 45, 33, 39. And then it continued. So it just piled all of the numbers it found into one contiguous array. This is where we need to reshape.
Mine's got an issue.
Mm-hmm.
It doesn't like.
You do have data. If you want to redo this and you already closed the file, you can't do it anymore. But you do have the data, so or is this from the previous? No. So your data is trying to do print shape. Yeah, you have the data. If you now want to go back, so I have the data. Let's just go back. If I want to re-execute this, the file is not open anymore. Okay? So if I want to do this, it's going to have an error. Did you catch this? So I did everything. I closed the file. And now I want to kind of do in the middle of operation. No, I got to do this first. I have to open the file again and then open. Then it's fine. Then it's fine. Yeah? So for np from file, the file has to be open already. And as you make mistakes, go reopen the file again. Okay? Actually, what would be the best in this case, and I'm going to just do that. I wanted to print this first line, but actually it's good to have everything in one so that you always execute everything. Open, read, close, and you're done. Okay? And I'm going to delete this cell. Great. Now, one last thing before I can actually use the data. I'd like to grab the month separately, high temperature, low temperature, average temperature. So I'm going to reshape. How do I reshape? Do you remember? Oh. Is equal to? What do I write? How many rows? Well, 4. Let's see if this works. I don't know. I'm just supposedly doing what you're telling me to do. Oh, it works. How does reshape work? If I tell it to do 12 by 4, I have 48 points. It can do that. 12 times 4 is 48. Okay? I could tell it to do 24 by 2, but that wouldn't make sense here. It would do it. And it's going to populate first row with data as it comes. And then it's going to switch to the next row of 4, because rows have 4. And that works here. That's why we're asking it to do it. And now if I actually want to grab this high temperature, how do I grab second column of this? What do I type in?
1, colon,
Data, I hope.
sure.
Now what?
Is it parentheses?
So 1 would be, or 0 would be very first entry, right?
Yeah.
That's 1. That's correct.
So you want
I want
1 colon
this column.
0, comma 12. 1 colon 0, comma 12.
1 column 0, comma 12. Mm-mm. So if I want everybody in a row or column, I can just put colon, comma 1. So this is column 0, column 1, column 2, column 3. This is array of 45, 50, 56. Let's see. 45, 50, 56. That's correct. What's grabbing is just the one-dimensional array, so this is now just one-dimensional array. If I grab 0th column, 1, 2, 3, 4, 5, 6, 7, and so forth. Cool. If I want first row, that's that 0th row, rather, in Python. Yes? So if I just wanted to work with this high temperature, this is my numbers, and I can work with them. You know how to plot, right? So your little quiz assignment for next time will be to plot this data on the single plot. Can you create a quiz assignment, please? So from here on, okay, I want to plot high temperature versus month, low temperature versus month, and average temperature versus month with 3 different types of symbols and no lines. You pick the symbols. If you want to be picky about colors, you can. So plot these temperatures on the same graph. Okay? Grab these 3 columns and plot them. Okay? I told you the key thing, how to get the information, right? So you need to plot this versus this 0th column, right? Then this versus this column, this versus this column, all on one plot. Okay? And please annotate the plot. Put a legend on it and call the x-axis with the month. Say month, temperature versus month. Okay? All right? And I will see you on Wednesday. So did you get all of that when you to create? He wasn't paying attention. Yeah, he's grading. All right. That's okay.